and welcome to this course, Learn NoSQL Databases, the complete MongoDB Bootcamp 2019. So, we will start off by learning about what is NoSQL, then we will move on to what data types is available within NoSQL, and then we will be installing a MongoDB where we'll be doing a lot of practical exercises throughout this course. So, in this course you will be learning all the basic principles about NoSQL, and we will be doing so with the use of MongoDB, which is a NoSQL database. So, first of all, what is NoSQL? A lot of people think that NoSQL stands for No SQL, meaning that no standard query language, but it actually stands for not only SQL. And NoSQL really covers any database that is not a traditional relational database. And NoSQL enables you to store your data in a much more fitting way, because you have a lot of freedom in NoSQL, where in relational databases you rely on this table column row structure, whereas you are totally free of this in a NoSQL database. And the reason why we are using MongoDB in this course is simply because it is open source, it is one of the most popular NoSQL, and there is a large community behind it, meaning that when you are done with this course and you need to develop things on your own, you can quickly search for advice and find answers for your questions just by Googling, because MongoDB have such a large community which has probably already solved the problems that you might have later on. So, when you're choosing between a relational database management system or NoSQL, or maybe both, there are some questions that you might ask yourself. So the questions is listed right here. So you could ask yourself, what does my data look like? How is the current data stored? Is it already stored in a relational database? Or is it already in NoSQL? Because if it is already stored in a relational database, you need to figure out if is it worth the time of transition to a NoSQL database. And then you may ask yourself, how important is the guaranteed accuracy of the database transactions, and how important is the speed of the database. And maybe you should simply split your data up such that you have the best of both worlds, meaning that you will have some of your data in a relational structure and some of the other data like comments and blog posts and so on in a NoSQL, which is much more fitting for such type of data. So, MongoDB highlighted. So, NoSQL is based on a document store model, meaning that you will have documents instead of tables. So we will not be storing our data like you might see in a relational database in tables with rows and columns, but we will be based on a much more document-like approach. And the data that we are storing is either in binary JSON or BSON. And some of you might already be familiar with JSON because it's a very popular structure, and it is used a lot within APIs and JavaScript. So if you don't know what JSON look like, don't worry, you will be seeing such structure in the next lecture. And besides that, MongoDB have also very high performance, and it is highly scalability. And you are just free of SQL injections, meaning that some of the downside with relational databases such as MySQL is that you can inject SQL commands in your queries and manipulate with the data when you are having a live running system, which is not possible using a NoSQL database. So this was a quick overview of some of the highlights and basic terms regarding to NoSQL and MongoDB. And now let's head on to the next lecture. So, MongoDB is a document-oriented database. And what document-oriented database means, it is that we can store all our data relating to a single entity within a document. So this was what I spoke about in the first lecture, the JSON format, what you see right here, where we have all the data within an enclosed collection. So we have the title, and then we have the value of that key, and then we have a version, we have keywords, and as you see right here, we have another object within this main object right here, because that is actually possible in a NoSQL database. So instead of having a relational database where we have different rows containing different data based on columns and maybe be referenced and related to another table containing other information, we will have all the data about an entity within a single document, like we see right here. And it will follow this approach where we have a key and we have a value for that. Similar to when you are programming, you have variables and you have some values for these variables. And when we get into data types in the next lecture, you will see that this is very similar to programming, for example in JavaScript or Java, where we have strings and we have integers and regular expressions and so on. And basically the maximum size of such a document is 16 megabyte, which is quite a lot. So you can actually store a lot of information within such a document. But if you have more than one document, you can group them together, and it is called a collection. So when you have multiple documents stored together, you're having a collection of documents, which is quite similar to a table in a traditional SQL relational database. So now that we know what document-oriented databases are, it's time to look at the data types that is available within the MongoDB, which is our NoSQL database for this course. See you in the next lecture. So, in this lecture we will touch upon the Mongo data types, which is available within the MongoDB. As mentioned in the last lecture, many of the types that you see in the MongoDB is similar to if you have tried programming before, such as Java, C#, or any type-oriented programming language. So you will definitely see some similarities and some well-known types right here, such as string, double, boolean, date, array, and timestamp, which is basically datetime or local datetime based on programming language you have been playing around with. But if you are all new to programming and databases in general, and you have never seen some of these before, don't worry. You will learn all the things you need within this course, so I will teach you each of them in future lectures, where we will be developing our data model, and we will be touching upon some of these. And when we are developing a data model, there are some questions that we need to ask ourselves, because the type of data that we choose to store do matter, because some data types are efficient for some stuff, where others are efficient for other stuff. And as we see right here in the example, which were displayed in the last lecture as well, we see that we have string values right here, meaning a textual representation, which can be seen with these quotation marks right here, where we have the string, or the text, learn NoSQL databases. But in the version right here, we see no quotation marks, and we see that this has another color, it is yellow. This is because this is an integer, which is another data type, and integers contain whole numbers, whereas the data type double, for example, will contain a decimal value. And the keywords right here is actually several string values. As we see here, we have one value, then we have a comma, we have another value, and then the last one right here. This is because the value we see right here is an array. So when we are developing our data model, we can ask ourselves these questions. What basic objects will my application be using? So if you are making your NoSQL to match an application where you have a lot of text, then it is not smart for you to have, for example, all integers, because, well, you can be stored in binary, but it is much more efficient to store the text directly. And if you have multiple values connected to each other, it might be efficient to have an array, because then you can, in your application, just loop over this array to display the different values. So you could ask yourself, what is the relationship between the different objects? Is it one-to-one, one-to-many, or many-to-many? And how will these objects be accessed? Is it by ID? Is it by the property value? or is it by comparing different parameters? And how often will these objects change? So these are some key questions that you need to ask yourself when you are planning your data model. So now you know some basic types within MongoDB, and we have touched upon a few questions. We are not yet able to answer these questions, but when we get to the lecture about planning our data model, we will be retouching these questions, and we will be answering them based on an example case that we will be building in this this MongoDB NoSQL database course. So I will see you in the next lecture. So now that we know some basic theory about MongoDB and NoSQL in terms of what it stands for, what document oriented is, what data type it contains, and how a document actually looks like in JSON format, it's time for us to install the MongoDB, which, as mentioned previously, will be the one that we use throughout this course to learn NoSQL and how such databases work. So you will go to Google, type MongoDB, take the first link, mongodb.com, enter it, then you go up to products, then under software you choose MongoDB Server, then you pick the version that is matching your operation system. For my case, it already chose the right system. I'm running Windows 46-bit or 64-bit, and I will just take this MSI installer instead of the zip. So you click download and wait for the installation file to download on your computer. Once the download of the installation file has completed, you click it in order to install the MongoDB on your operation system. So basically you just follow the installation, click next. I have already installed mine, so I will just click change and I will say next. And this is a window that you should be seeing when you are installing a fresh installation, and you will just keep this run service as network service user and install MongoDB as a service, and then you can choose here where you want the data directory to be. So you click next, and then you also need to have this enabled. It should be enabled automatically, but if it is not, be sure to click this, because we want to install MongoDB Compass, which is a graphical user interface for the MongoDB, such that we can play around with it in a nice graphical manner instead of using the command line. So we click next, and then you basically just say install. In your case, mine was changed, and I will also have an error, you should not, and we just say like so. Once the installation has completed, which for your case should happen without errors because it is for hopefully the first time you install it, you can go to MongoDB, find the MongoDB Compass community application, you will open it, and then it will load for a few seconds. And as you see here, this is an application which has a graphical user interface compared compared to the terminal, which we were in need of using if we hadn't installed this MongoDB Compass application. Once it is finished load, you should see a page similar to this, where you can connect to host. It is auto set to localhost and a port. We will not be changing any of these because we are just using localhost for this entire course. So we will just click connect, and it will connect to our local host, meaning the MongoDB server running locally on our machine. And then we will have the database names right here, and we can create new database, or we can go into the admin one. And as you see here, we can create a collection, which you hopefully remember from the last lecture, where when you have multiple documents together, you are having a collection. So from here, we will be starting our first step towards mastering the MongoDB and the NoSQL framework. So see you in the next lecture. So if you are seeing this error message when you're trying to connect, MongoDB not running on the provided host and port, it means that you have no active server running on your local host. In order to fix this, we will navigate to the command prompt, and then we will enter the MongoDB server file by saying cd, like so. It is typically placed under your program files, MongoDB server, the version you have, and then the bin. You can also navigate to it manually using this graphical folder directory here, where you see the exact path and you can navigate into it. But we will keep it in the console because we need to see the output of this operation. And if we just run an application from within the folder, if there is an error or so, it will just shut down the terminal right immediately, meaning that we are not able to see what might be wrong. So we will be typing MongoDB, and let's see, we have an error. So as you see right here, our data directory cdata.db was not found. In order to fix this, we just simply go to the C directory, create a new folder, data, and again we create a folder db, like so. Now we can exit this, run the command again, and as you see, we are now ready to go in, click connect, and we are now again connected to our local MongoDB. So we can go into our admin and we are ready to start. So now that we have been set up MongoDB Server and MongoDB Compass, it's time to create our first collection. We will create our first collection and name it courses. Click create collection. As you see right here, we now have course. It has 0 documents and a total document size of 0.0 bytes. So let's enter the courses collection and then click on the insert document to create our first document. So in this first document, we will be making the same document. We had an example right here. So we will be typing title as the first field, and the value of that is learn NoSQL databases, and it is a string, which we can select right here. And the next one is version, and this is actually not a string, it is an integer. So we'll just take integer 64. It is giving us an error because we have no value yet, so we type 1. The next value is keywords, and that was not a string, but that was an array. So in index 1, oh, I misspelled here, keywords. So at index 1, meaning the first element of the array, we had MongoDB. At index 2, we had DB. At index at index 2, which is the third value, we had Udemy, like so. So we click plus right here. Oh, we don't want that one, so we say like so. Add a new field after the array keywords, and that was instructor. And that contained another object, so we will say object, and that object contained the value name, which were Mark, and last name Nielsen. So now we have an exact copy of the example that we saw from previous lectures. So we'll click insert, and now we have our first document, and as you see right here, we have keywords, which is an array, so we can expand this to see the values in here, and we have the object, which is Mark Nielsen. So this is the document overview. We can also go into the table view, meaning that we will see it in a way that you normally see it in relational databases. And as you see right here, we have some difficulties presenting it in the right way like this, because we actually have arrays and objects instead of main values like strings. But in here it is no problem, and we even have a unique ID for this particular document. So we have now created our first document, and I will see you in the next lecture. So now, based on the last section, you should have two documents within your MongoDB. You have the first one, which we created together, which were the one I used as an example in the very first lectures, which is the object document right here, where we have this tile, we have array and so on, and we have an object within this instructor. Then you got an assignment where you were to create your own document, which you should use 3 different data types. I have an example document right here, even though I only use 2 different data types, an array and basically strings for the rest. But at least you should have 2 documents. So in this section of the course, we will be looking into aggregations and how we can use that to manipulate our data. The smart thing about aggregation is that we can manipulate our data locally on the server, meaning that instead of just sending all the data to our application, which is typically a web application running on some separate server, we will have the benefit of getting the database to spend the resources on manipulating the data, such that our web server is not getting overloaded with the data manipulation. So a little example of aggregation and how it works within the MongoDB Compass is that you can, if you are not seeing this, click Add Stage, and of course you should be able to see your documents right here, the 2 documents. If you're not seeing all the documents that you have right here, you can simply just click this and it will refresh this frame right here. So a simple aggregation is the match. So now we can write a query and we will say, let me see, I want the website. So we'll just output a document where it has a website element matching squaretechacademy.com, which is, by the way, my site, and I encourage you to check it out for more resources and videos as well. So we type website, and then we say .squaretechacademy.com, and as you see here, we get this document returned because currently that is the only document that is matching the little query we have made here, the match query, where it should have an element website matching squaretechacademy.com. So this was a short introduction to why aggregation is beneficial, because we can run it on the MongoDB server instead of our front end. So in the following lectures we will be looking into different queries that we can write in order to manipulate our data, because as you see here, there are a lot of options. We will not be covering all of them, but I will show you some beneficial ones that you might want to use within your own application. So see you in the next lecture. So in this video we will be learning about the sort aggregation. So we will go down in the one right here, find sort, and then we can sort our documents based on a field ID and a given sort order for that field ID. So we can, for example, say version, and for that particular example I have created a new document, just this basic one with a version of 2, where we have version 1 here, 1, just to illustrate how this works. So we type in the field that we want to search or sort on, which could be any field, and then you type in a value right here. So if you type in 1 as a sort order, and we'll remove the comma because we're only sorting on this one field, so you can basically sort on multiple fields at a time by just separating by a comma. But if we delete the comma, like so, as we see right here, we have now sorted in an ascending order. And as you see here, the first document does not even have the version field in, so this is put at index 0, and then the next document is ascending by 1, meaning that we have version 1, now version is actually present, and then we have the last document, which is the highest value in this sort, with the version number of 2. So with a integer of 1, we are sorting in ascending order, whereas if we type -1, we are sorting in descending order, and now the list is turned around, so now we are sorting from the highest number down to the lowest, so version 2 is now the highest, version 1 is in the middle again, and we have the document with no version field present at all at the end. So this is how you sort based on ascending and descending order. And remember, you can sort multiple fields at a time, just separate by a comma and enter the next value. So if we, for example, type title as our field, we would say title, and let's say 1 there as well. Then you see here that since we are again sorting in ascending order, we are seeing that this document, which does not have a title and no version number, is put in the start, because we are going from the low value to the high value, and then since both of these have title available and this title is longer than this one, we are still also sorting on version number, so the version here is higher, meaning that it is getting overruled because this is the first value. So this is how you can sort based on fields and ascending and descending order. See you in the next lecture. So in this next example, I have created these 4 documents, which is very basic documents. So we have a name and an amount, and we should be able to now to fetch result based on the amount that each of these fictive persons have on their bank account. So we go in, we update this, and as you see right here, we will be using the match, and instead of the version, since that is now not available, probably I will just reset this such that you see once you click match. This is also one of the nice things about MongoDB Compass, and the reason why I'm not going over all of these operators, because when you click an operator, you will get a description of what this operator is for and a basic query for how you should fill the values out so that you can use the operator. So for max, for example, we can say in the query we want to base it on amount, so we simply say amount, and then we say I want to see all of the persons in my database that has more than $400 on their account. So I will be typing $sign right here, and that is not because we are looking for amount in dollar, but you just need $signs when working with operators and so on. And then you say gt greater than, and then I say 400, and we close this off, and now I get returned that Lars and Amanda has more than 400 on their account. So if I then type lt less than, I should not be able to see Lars and Amanda, because now I'm seeing the people that have less than $400 on their account. So this is how you use the match operator, and again you can have multiple search parameters within. You are just separating by comma, which we learned in the last lecture, and then I will see you in the next lecture. So in this lecture we will see how we can subtract amounts from our users and display it. So we are not actually subtracting from the direct value that is stored in the database, but the value that is returned to us is getting subtracted such that we can see, do they have money to, for example, enter a movie feeder. So we will go into aggregation, type add stage, and then we will select, let me see where it is, project. So this will be for all our documents. So project is currently applied to all documents since we haven't specified otherwise. So what we want is to return each of our fictive persons with the amount that they have left if they, for example, use $20 to enter to see a movie. So we will type left, which is a new field that will be returned because left is currently not on any of these. So we'll say left, and then we will say there it is, say sum, and then we say, oops, like so. So we say sum, and we need this, and then we say we want the sum from the amount field, which is present on all of them, and then we say comma, and then we say minus 20. Oh, I forgot to close this off, like so. And so we are getting a new field called left returned, where we can see whether the amount that they have on their account is going to a minus if they pay $20 to enter to see this movie. So if we are using this in our web application and we are returning and is returned with a minus value, then we know that this person should not be allowed to buy the ticket because he simply can't afford it. So we have not yet charged them with this amount because their original value is still stored in their bank account, but we are just doing a check right here to see if they can afford it. So this was the project operator, which can be applied, which is applied to all the documents, and you are able to add new fields in the return string, or you are able to change the name of some of them and do a lot of different operations on them. So in this lecture we will see the group operator. I have created 2 new documents since the last lecture. I have created another one with the name of Peter and $100 in the amount, and I have created another with Lars, and he has an amount as well. So in this example you should see all these as bank records where people are depositing cash into their bank account. So we can see that the first one has deposited 200, then Peter comes with 150, Lars with 500, and so on, and then again Peter deposited another 100, and Lars comes again. So now we want to make a summation about the total amount that our 4 fake citizens here have on their bank account. So we go into aggregation, remember to refresh such that you have all the documents right here. So we only want to get 4 documents returned with a summation of their total amount. So what we will do is go into this, find group, and then in the first one right here for the ID we will type the field of their name, because we will use the name as the ID such that documents with similar name ID will be seen as equals. And then we will take the field right here, and then we will say total amount, because that is the new field value we want to return, their total amount based on all their deposits. And then we want the sum operator, so we say sum, and then we want the amount because it is the amount that we want the summation of. So we type the amount right here, and then we'll remove this pointing arrow, like so. We will see that we have 4 documents returned based on this operator, and we see that Lars has a total amount of 530, and let's see if that match. First he deposited 500, and then another 30 right there, and Peter has deposited 100 and 150, so a total of 250. So now we have used the group operator to sum up the amount that our 4 citizens here has deposited over the entire lifespan of the database, which is of course a very limited lifetime. But this was the group operator. See you in the next lecture. So now that we have played around in the MongoDB Compass graphical user interface right here, it's time for us to move into the MongoDB Shell, where it is easier for us to create MongoDB scripts and manipulate and use our database. So in order to do so, we need a IDE, and we'll be using Atom for this course, so you can navigate it to using this web page right here. It is an open source code IDE, so you should be able to download it for free. All you have to do is enter the site, click download. Once the file has been saved, open it and install it. So once the file has been downloaded, double click and open it. Once the installation has completed, Atom should start up and you should see a similar interface like this. Once that is done, you're ready to move on to the next lecture. So now that we have Atom installed, it's time to see how we can access the MongoDB shell. In order to do so, you will open the command prompt, type cd, navigate to the installation folder just like we have done before, but whereas you before clicked Mongo and a D to get the MongoDB service up and running so that we can connect to it using MongoDB Compass, you will now just type Mongo without the D. And we are actually now within the MongoDB shell, and we can execute command from within here and actually control our entire database and service from this terminal. So this is the terminal shell that we are going to use later in this lecture when we start to write scripts in here. Then we will write the scripts in the text editor and execute them within the Mongo shell. So for example, you can see the database that you have currently in your MongoDB service. Just an example, you can type show DBs and you should see the same 3 databases as you did in the MongoDB Compass. So this is how to access the MongoDB shell. I'll see you in the next lecture. So now that we have learned how we can use the MongoDB shell and we have the Atom IDE installed, we will be starting writing our first scripts to be inserted into our database. So I will just make this a bit more suitable for what we're going to do, like so. So the first thing that we are going to do is to create a new file. You can simply just click new file, like so, new file, and then you simply just save it, and then you save it as, you can just save it here, so we'll call this MongoDB script.js for JavaScript. Okay, so we just save it in the desktop, it doesn't matter, like so. Okay, so we are going to insert some documents into our row. So what we're going to do is type db.students, and this is to be the collection that we want to insert into. So if we go into the Mongo Compass, remember that a collection was, for example, the courses, which we have used in the last lectures. But now we want to make a new collection named students, and since we don't have it yet, MongoDB will automatically create it just when we write it out, followed by the DB. So then we say that we want to insert many, and we want to have an array of documents. So we say name for our students, so we say name, and the first should be Mark. The reason why we saved in the JavaScript is to get some colors and stuff on, so that we can see the difference between what we are writing instead of just all gray text. So we'll say age, and then we'll have a field called enrolled class, which is math, and then a comma to indicate that we have a new document as well. So we'll just copy this a few times. Then we change the name to something new so that we can see that we have our different students. And their age as well should be different, just to get an indication of how this works. And then some of them should be enrolled in computer science class, whereas the rest is enrolled in the math class. So we just copy this, then we go down here to our MongoDB Shell, and then we say use admin, and now we have switched to DB admin. So by inserting this, but to capitalize the M, then we will copy it again and right click in the cell, type enter, and acknowledge true, inserts ID, meaning that this is the ID that each of our documents has received because it has a unique ID. And you will see that it is similar right to the end where it has 2, 3, 4, 5, 6. And now we can go to our MongoDB Compass, update this, and now we see that we have a new students collection with the students that we just created. So instead of doing it through this graphical user interface, you can write in a text editor the commands that we want to execute and simply just paste it into the MongoDB shell, or you can also write it directly in the MongoDB shell, but I find it more suitable to do it in here in order to manipulate and see if there are any errors before typing it in right here. So now that we have inserted our students, it's time to go a bit further in the MongoDB shell. See you in the next lecture. So now that we have inserted these 5 students, we will try to look up the students who has enrolled in the computer science class. So the way that we're going to do this is again typing DB and then students, because we inserted them in the students collection, and then .find, and here we simply declare what kind of field we are looking for. So we are looking for the enrolled class, and we want to have the ones that is enrolled in computer science. So we will just write computer science, and that is basically it. So by copying this one, going down to the MongoDB shell, right click to paste it, enter, and MongoDB will return the documents that contains an enrolled class field with the value of computer science. So this is a way to look up your different documents based on a given value that you are interested in. And as we saw in the previous lectures with the aggregation, you can also use find and values with greater than and so on. An example of such is to take, for example, the age and then make a lookup based on their age. So we will type enrolled, type age, and then we will say $, greater than, and then we will say 24. So copy this, again put it down, paste, and then we get returned the document students who has an age greater than 24. So we have currently 2 of these students, which is Tim and Camilla. So this is how you can use the find operator to look up documents and data in your MongoDB database. So now we want to make an update to the documents that we have. So we will just remove this parameter to see the current documents that we have. This will return all documents, and as you see here, they are exactly as they are now. So now we'll be making an update such that the students who is currently enrolled in the math class will be now enrolled in the computer science class. So the way that we're going to do so is typing db and again the collections students, and then we type update, and within this we will say enrolled class where we have math, and then we say the operator set, and then we want that to be computer science, and then we copy this one right here, paste it down here, and let's see, we have an error. So we forgot two things. We need to do it like this, and then of course we need to say that the parameter, or the field that we're going to set is again the enrolled class, like so. So we copy this, paste it, and let's see if we use the find. We now have that our top user right here, the first one, is now enrolled in computer science because we updated like one, meaning that we updated the first row. So if we want to update all of them, we need to make the following expression. Where we had before math for 3 of them, we now have math for only 2 of them. So in order to update multiple documents, we will add a little field value of true. So we'll say multi, and that should be true. Then we will copy this again, paste it to the MongoDB Shell, run this, and we see now n modified is 2 because we had 2 left with math. So if we use the operator db students find, we now see that all of our students is enrolled in the computer science class. And if we go to our MongoDB compass and we update this, we now see all values is updated to computer science. So now that we have seen how we can insert, find and update our documents within our students collection, it's time to see how we can remove documents as well. Let's say that we have a user that is no longer part of our class and we need to remove him from our database of enrolled students. In order to do so, we will use the remove statement. So what you have to do is type db as we are used to, and then students, to be sure that you're using the right collection, so our students collection, and then as we have done before with find and update, you type remove, and then you specify who you want to remove. In this particular set we have a user named Tim, and I will remove Tim because he is no longer part of the computer science class and is no longer needed to be in our little data set right here. So I will say remove of name, and then we will say Tim, and then I will copy this, right click to get it taken in, and as we see here, right result, we have removed one object. So if we take the find statement and use that, we now see that whereas Tim before was part of the set, we are no longer seeing him because we have simply removed that document. And you can also see this if you go to your MongoDB compass, and as you see, he was part of the dataset, but if we update this, he has now been removed and are no longer part of this collection of documents. So this was how you could remove documents from a collection. See you in the next video. So in this section we'll be looking at users and user roles within the MongoDB database server. So far we have been using the admin database, which were automatically created when we installed MongoDB Server on our computer. The special thing about the admin database is that all the users that you create in the admin database has special privileges, meaning that if you, for instance, create a new database and make some users for that particular database, they will only have access and roles within that database, but the users that you create in the admin database will also have roles in your other database, because the admin is like the root database in the MongoDB database system. So when you are logging in as a user to a database, MongoDB will not only search for user credentials in that particular database, but it will also go up and search in the admin database. So you need to be aware of this when you're creating users. And this also means that if you want to create a user that have access to multiple databases, it has to be created in the admin database, because you cannot create a user in another database that have access to multiple databases, because that particular user will only be within that single database. All this will be something that we will learn in this section, so don't worry if it seems complicated. We will start off slow by creating a new database that is not our admin database, and then we will start from there and work our way up. See you in the next lecture. So we'll start off by creating a new database, which we are going to add users to later on. So remember that we have used the use command before when we switched to the database admin, so use admin, and we switched to the DB admin. It is the same command that we are using when creating a new database, because if we type use and then a name that MongoDB is not associating with a database, it will automatically create that database. So if we type use and then new DB, we see that Mongo says switch to DB new DB. It is a silly name, but yeah, you get the point. And if we type DB to see what database we're currently in, we see that we are now in new DB. But if we need to see what databases are on our MongoDB server, we can type show DBs, and what you will notice is that currently our new DB is not present on this list, and you can not see it in the MongoDB compass as well if you're updating, because the database will first get shown when you start to add something into it, because currently there is no collections, no document, nothing in it. So we'll be inserting a new element. So in this one maybe we will have animals, so we say DB animals. So this will be a collection of documents with elements, so this is the collection name, animals, and then we say insert, and then we make it as a function, or maybe we will do it up here. So db.animals.insert, and then we have this, and then we will say name of our animals. So the first animal will be a lion, and since this is only to illustrate how databases are created and used and so on, we don't need much more than just the name of this. So we take this, paste it in, and as we see, inserted 1, and if we now type show DBs, we now see that the new DB is present on the list, and if we go update MongoDB, it is also in this list right here. And if we enter it, we see that we have the collection animals, and that collection contains one document with our animal with name lion. So this is how you create a new database. In the next lecture, we will be creating users on this new database. So now that we have our new DB and we have inserted a collection of animals with a document lion, it's time to create our first user. So we will say db.add user, And remember that you have to be in the new DB, and to check that, just type DB, and we are currently in the right database, so we can type DB.add user. Oh, again, I should probably do it up here, then it's much easier. So db.add user, and then we will say user, and this is the name of that user, so we will say animal user, because this user is going to be able to read from the database, and it is basically a database for animals. So we say, and then the password for this user will just be test, and then the role of that user will basically just be a read role, so we will say read. And that is all we need. We will copy this. So by typing the role read, this user will not be able to write anything to the database. He will only be able to read all the documents that are in the database. So if we type this in, and let's see, oh, it's not add, of course, it's create user. So let's take this, copy it in, and as we see, successfully added user. And if we now type show users, we see that we have this DB is the new DB, the user is animal user, and he has an ID which is saying that in the new DB, and his username, we can see his role and what database he's associated with. So that was how you created a new user. So in the last lecture we created our animal user account with the role permission of read. But before we can turn on authentication for the MongoDB server, we will need to create admin user to the admin database. So what we will do is to switch to admin database, so we'll say use admin and type db, and if we say show users, we see there are currently no users. So what we will do is to use the create users, and we will call this admin and just password admin. Never do that on a online system. This is on localhost, so it's fine. And then we'll give the role of user admin any database. Then we will copy this, type it in, and now we have user admin. And if you show type users, we see that we have admin user and the admin database, and we are not sharing our animal user because we are currently not in that database. So if we type use animals, oh, it was use new db, and we say show users, we now see the user for that database. So now it's time to turn on authentication in our data. So what we have to do is type the following command. So mongodb, and then we say db path, and then we need to specify where we have our data. In my case, it's on the local disk, so I'll just copy this. And then we need to say auth for the authentication. So I will copy this, and then we will go into the command prompt right here. Oh, we will not do that. We will start a new command prompt. Then we will close the current session we have, meaning that we will lose the connection to the database. So we will close this, and then we simply go to the folder of our Mongo, which was this one. Remember, in your bin directory of the MongoDB server, you have the MongoD and the Mongo for the MongoDB Shell. So type cd and into the bin. And now that we are in that directory, we can just copy it down here. We can copy this line right here. Oh, I forgot that it's not path, it's it patch like so. So currently the connection is now up again, and we should be able to log in. So a fresh command prompt, we will say Mongo, and then the database that we're trying to connect to, new DB, and then we will say user, and it is animal user. The password is test, and the authentication database is also new DB. Then we type enter, and now we have connected to the MongoDB. And if we type show DB, we are only seeing this single database because our user does not have the privilege to see any other databases. And since we only gave it a read, write, if we try to take this DB animal, type it in, we will see an error because, as you see here, codename unauthorized. So we do not have access to insert anything into this database. We are only allowed to read. So if you type db.animals.find, we can easily read because that is the authorization that we have been given as this user. So this is how you log in with a new user. So now that we have seen how to log into our read user for the new DB, we want to see how we can log into our admin user and then create a new write user which has the right access to our database. So we start by navigating to where we have placed the MongoDB server, and then we type Mongo because we want to open a Mongo Shell with authentication to our MongoDB server. And remember that you still have to have the MongoDB server up and running. So Mongo, and we want to connect to new DB. And remember that we created the admin user right here, so that is the one we will be using to log in, because the other user that we have, the test user, only have read access, so it can't be used to create any new user. So we say u and then admin, and the password is again admin, and we want to authenticate to database new DB. Oh, let's see, we have an authentication, and that is because, of course, we first want to use our admin user to log in to admin new DB, like so. And now we are connected, and then we can say show DBs. And then you see right here we have the databases. So we will just switch to new DB. And now we have switched to the new DB database, which is where we have our current test user. So we'll be creating a new user, and we will call this write test, and password will just be test read write access, like so. Then we will copy this, paste it in, and as we see, successfully added user write test with the role read write. So now that we have this new user, we are actually able to switch through it and read and write some new data to our database, whereas in the other user we could only read because we got an unauthorized code when we tried to write to the database. So we're going to switch user, so we'll close this session right here, and we still have this up and running. And what we're going to do is to be sure that we have the path here such that it is easy to copy. So we'll go back into the command prompt, then we will navigate to the directory, take this down here again, and then we will basically just say again Mongo, and we want to connect to new DB. The user is write test, the password is test, and we want to say our authentication database is new DB, and now we are logged in, and we can check the DBs. So we say show DBs, and as you see, we only see this one new DB because we are this is a local user for that database alone, whereas the admin user were created in the admin database, which means that it has access to all the databases because of the role we defined. So if we take and write db dot animals dot find, we can see that we have the authorization to read, but let's see if we can insert a new animal. So we'll just say monkey, copy this, paste it, and again we see inserted one. So if we execute this again, we are now able to read as well. So now we have a user that is capable of reading and writing to the database